Hello, everyone. Welcome to this session. Now that we already knew how to calculate the time and space complexity of an algorithm, as well as the asymptotic notations, for today we are going to focus on creating abstract data type. So the intended learning outcomes for this are the discussed to the importance of abstract data type, to identify the four operations of data type, and then we have to create ADT in solving machine problems. So data abstraction is the ability to view something as a high level object, and then while temporarily ignoring the enormous amount of underlying detail associated with that object. Also, it is viewing something only in terms of its external appearance without regards to its internal implementation. And to it actually focuses on giving attention to the what rather than the how. So example, we have organization, body organs, or any object or actually program. So like body organs, we we have reproductive system, we have nervous system. We don't actually have to know what is it's made up of. Like only specific professionals should have known it, like surgeons or the doctors, and also in programming, like for an instance, a a mouse. So a mouse, it's a pointing device. All we just need to do is uh, the its functionality, how to use them. But rather than focusing on what is it made up of, we don't have to. It doesn't really matter actually. Okay, but of course, as a programmer, we have to, as I've said before, we have to be to play both worlds, to be a creator of our own ADT, and at the same time to test, to use our ADT so that also we are able to assess rather the ability or the sufficiency of our ADT. So what's procedural abstraction? So let's say for an instance we have here a method sum of integers which has two uh, types or two arguments, the x and y variables, and then inside of that function or method, the procedures is going to be adding the two integers that are being entered by the users or the user. And then after that, when we call a specific method, and then we assign the value of 4 to x and then the value of 6 to y, and then the result of that will be assigned to the variable sum, which actually results to or yields to the value of 10. So what I'm trying to elaborate here is that we don't actually really care of what happens inside of the function body, but rather what the function does and how to actually use the sum of integer function or method. So that's procedural abstraction. So we focus on the how rather than the what. Okay. Now, what are the benefits of abstraction? So first is it helps us to understand complex system. So as we all know, there are actually many different data abstraction in programming. Like for an instance, you want to reverse a specific string. Instead of you write a program or a procedure to reverse a string, you can actually use the method reverse, which is actually built in, and then you just call it and take advantage of it, and then you're able to reverse without actually doing your own codes. And that's something that you can actually benefit out of it. So being able to only give you the function, the operations rule, and then eventually call it and then apply it in your program. So basically, it's instead of knowing what's inside of it, you are now just at least has the idea of how this specific method is going to be used in your program. And then the second one is to make things easy to observe and manipulate. Now, data abstraction has 7 attributes. Example, we have int x as a declaration or a statement in Java. So we have here a name. The first attribute is which is a textual label used to refer that variable or data in the text of program. So in the given statement, the example of that is, of course, the name of the variable, which is x. Next is the address. Address denotes the location in the memory. Example of that is memory location. And then the value, the quantity which that variable represents. So it's assigned or either it's an input, lifetime, interval of time during the execution of a program in which the variable is said to be exist or to exist. So example of that is if it's runtime, it's a compile time, and then we have here the scope, which is the set of statements in the text of the source or the program in which the variable is actually said to be visible. So this, an example of that is the block of code, which is actually the scope of your uh, data abstraction. And then we have the type. The type is the set of values which we can be assigned to the value attribute. And then the set of operations which can be performed on the variable. I'm sorry for that. Now, if you are hearing those sounds, then example of that is actually an int type. And then we have here a, a size. A size means the amount of storage required to represent the variable, which is in our previous discussion or topics, we already discussed about the different types and its byte size that is going to be consumed once we are going to use them. So int is of 2 bytes. All right. So we have uh, here data types has actually 3 levels. We have the hardware data types, the virtual data types, and the abstract data types. When we talk about hardware data types, it actually directly supported by the hardware. So these are integer, float, characters, and etc. and all other primitive types. We also have virtual data types, which are actually it does not actually exist in the sense that it's actually being directly represented by the hardware. the the compiler creates these data types like arrays, structures, sets, and pointers. And now we have also here an abstract data type. So when we speak of abstract data type, these are actually our ADTs, and this is our primary focus on this uh, entire course. So we are going to like model a specific or a certain algorithm, and then we are going to create our own ADT out of it, like stack. That is a LIFO or last in first out algorithm, and later on we in our succeeding topic we are going to create our own ADT for that, like queue and vectors for dynamic arrays, array list, linked list, and all other abstract data types that are actually available in Java. So here are the 4 factors in ADT specifications. We have the domain of values. The domain of values are the set of values that may be assigned to a variables of its type. So it could be either atomic or composite. So when we say atomic, its domain of values is actually made up of non-decomposable or primitive elements. It's also known as simple. We also have composite. Values can be further divided into elements called components, and that is what we call data structures. And then we have the data types of components, the second factor, and then which actually talks about what types of data this ADT is or will contain. Is it all integers? Is it going to be all floats or the characters or a mix or a combination of data types? And then we have structural relationship between components. Like what type of structural relationship should the components have, or should the first element be accessed last, Or should the last element be accessed on the first or at the first? So should an element be connected to other elements, just like linked list? Okay. So another is the operations of the ADT, which we are going to also focus on later on in this topic. So next is we have what are the properties of an ADT? We but before that we will have to have differentiate first the data encapsulation and the information hiding. So data encapsulation is the process of packaging together a collection of data values together with the operation of those values. Example, we have values which is the maxed in, positive maxed in, and then negative maxed in. And then we have the operations positive, negative, and all other arithmetic operators. Now, when we speak of information hiding, we it's like masking the internal implementations of the ADT so that users do not have to know the messy or the gory details of the specifications of an ADT. So uh, basically, the operations are the only thing that are actually accessible to the user. So that's here. That's some of the this are actually being hidden. So what are the benefits of data abstractions through ADT? So we have security and software integrity, maintainability, sharing and reusability of software and intellectual manageability. So when we talk about security and software integrity, programmers controls access to all resources, guaranteeing that no improper, illegal, or potentially dangerous operations that can be carried out. When we talk about maintainability, it's like external module is actually dependent of the underlying implementation. So it could be like flexible or a cost-effective solution. And then we have here the sharing and reusability of software. It talks about an easy when it comes to importing, you have this easy to import through data encapsulation, or the code is being shared, which actually improves productivity. So it like in inheritance or something like that, or in OOP. So it's actually can be also cost effective as a solution. And then we have intellectual manageability, which to make things simple, being simple, or to simplify things out. And then something a solution that focuses on actually the bigger picture. Next is ADT class has two concepts about like syntax and semantics. When we speak of syntax, it's actually the format of the operations on the ADT. It will describe how we use an operation, although it does not tell us what the operation does. While semantics is actually this is something that describes the actions of an operation and the effects that this operation has on the other objects in the system. So as a summary of our topics for today, so abstraction is the ability to view something as a high-level object while temporarily ignoring the enormous amount of underlying detail associated with that object. So we have seven attributes of data structuring. So we have name, address, value, lifetime, scope, type, size, and there are three level of data types. We have a hardware data type, virtual data types, and abstract data type. So in our next discussion, we will be focusing on creating our own ADT. So that would be all for today, and thank you guys for listening. Have a great day. See you guys next meeting. Bye bye.